In this video, we're going to be having a look at the Grade 9 Common Questions booklet. This booklet will cover the quadratic simultaneous equations and proof. So following on, question 6 says solve the simultaneous equation x squared plus y squared equals 13 when x is equal to y minus 5. So you've got x squared plus y squared equals 13, and we're told that x is equal to y minus 5. So what we need to do is substitute in y minus 5 for wherever we see x. So x squared is going to be y minus 5 squared, because x is equal to y minus 5, plus y squared equals 13. So expanding this double bracket here, y minus 5 times y minus 5, we're going to get y squared minus 10y plus 25 plus y squared equals 13. So check out the link in the description below to the video where I've explained how to expand double brackets. We've got y squared plus y squared, which is 2y squared, minus 10y plus 25, and this is equal to 13. Now when we're solving quadratics, which is what we need to do, we need to get the right hand side equal to 0. So we're going to subtract 13 from both sides. So we're going to get 2y squared minus 10y, and then we're going to do 25 subtract 13, which is equal to 12. And this is equal to 0. So now we're going to solve this quadratic equation. We're going to use the maths method again. We've explained how to do this in a previous video, which I'll leave linked in the description. So 2 times 12 gives us this m number, which is 24. This a number is the middle number, which is negative 10. And then we think of two numbers that multiply together to give us 24 and add together to give us negative 10. So these two numbers are negative 6 and negative 4. So we get 2y squared minus 4y minus 6y plus 12 equals 0. And then we then factorize each half. So 2y out to the front, then inside y subtract 2, minus 6 out to the front, and then y subtract 2, and this is equal to 0. So one of the brackets will be 2y minus 6 from this part here, and then the other bracket will be y minus 2, and this is equal to 0. So if we've got two terms multiplied together that equals 0, one of the terms must equal 0. So either 2y minus 6 is equal to 0, which means if we add 6 to both sides, we get 2y equals 6, so y is equal to 3, or y minus 2 is equal to 0, so therefore y is equal to 2. So there are our y values, but we need to get our x values. We're told x is equal to y minus 5, so if we substitute in y equals 3, x is equal to 3 minus 5, which is equal to minus 2. So when y is equal to 3, x is equal to negative 2. And if we substitute y equals 2 into here, x will equal negative 3. So here we have our two solutions. Question 7 is also a solve simultaneous equations question involving quadratics. We've got x squared plus y squared equals 41 and y equals 2x minus 3. So x squared plus y squared is equal to 41 and y is equal to 2x minus 3. So we're going to substitute in y equals 2x minus 3 into the first equation. So x squared plus 2x minus 3 all squared equals 41. And we get x squared plus 4x squared minus 12x plus 9, and this is equal to 41. So this section here, I just expanded this double bracket out. Collecting like terms on the left hand side, we get 5x squared minus 12x plus 9 equals 41. And then if we subtract 41 from both sides to get this equal to 0, we're going to get 5x squared minus 12x, and 9 subtract 41. This is equal to negative 32. Again, we can use the maths method to solve this equation. So our m value is negative 32 times 5. This is equal to negative 160. And then our a number is this middle number in the quadratic, negative 12. So we need to think of two numbers that multiply together to make negative 160, but add together to make negative 12. So these two numbers will be negative 20 and 8. So negative 20 times 8, negative 160, and negative 20 plus 8 is negative 12. So writing these out in a line, we've got 5x squared, which is the first term, and then we put these two terms in the middle. So negative 20x plus 8x, and then stick this end value on the end. And then we're going to factorize half the equation. So bring a factor of 5x out to the front, x minus 4 inside, bring a factor of 8 out for this next expression, and then inside have x subtract 4. So one of the brackets will be 5x plus 8, and the other bracket will be x minus 4. This is equal to 0. So again, two terms multiply together to give us 0. One of the terms must equal 0. So either 5x plus 8 is equal to 0, which means that if we subtract 8 from both sides, 5x is equal to negative 8. So x is equal to negative 8 over 5. Or x minus 4 is equal to 0. So if we add 4 to both sides, x is equal to 4. We need our corresponding y values, so we're going to substitute in these two values to get our corresponding y's into equation 2. So if we do 2 times 4, that gives us 8, subtract 3, that gives us 5. So the corresponding y value for x equals 4 is y equals 5. And our corresponding y value for x is equal to negative 8 over 5. So 2 times negative 8 over 5, subtract 3. This gives us negative 31 over 5. So x equals negative 8 over 5, y equals negative 31 over 5, and x equals 4, y equals 5. Question 8 says, prove algebraically that the sum of any two odd numbers is even. So prove algebraically that the sum, so this means adding, of any two odd numbers is even. So an even number, when we're doing proof, is represented by 2n. So an odd number will be 2n plus 1. So we need to pick two odd numbers. So if 2n plus 1 is odd, then that means 2n plus 3 will also be odd. Now the sum means to add these together. So 2n plus 2n is 4n, and then 1 plus 3 is equal to 4. And we need to prove that it is always even. So if we pull out a factor of 2, and inside get 2n plus 2, then therefore this will always be even due to being a multiple of 2. Question 9 says, prove that for any integer n, n squared plus n is always even. So n squared plus n, if we factorize this expression here, we get n brackets n plus 1. So if n is an integer, then n plus 1 will be the next consecutive integer. If you multiply n by n plus 1, which is the next number, then this will always be even. So therefore, the product of two integers is always even. Question 10 says, prove that the sum of 3 consecutive even integers is divisible by 6. So 2n plus 2 plus 2n plus 4 plus 2n plus 6. So these are the 3 consecutive even integers. So collecting like terms, we're going to do 2n plus 2n plus 2n, which is equal to 6n. 6 plus 4 is 10, plus 2 is equal to 12. And then to prove that this is divisible by 6, we're going to bring a factor of 6 out to the front, and then inside get n plus 2. So therefore, divisible by 6 due to it being a multiple of 6. So this concludes part 2 of the grade 9 question booklet. Remember to drop a like and subscribe to the channel for more videos like this.